Hi everyone, this is Henry from Emesent. Today I'll be showing you how you can use user-selected targets and control points when capturing and processing hover map data. Control points will help you increase the accuracy of your scan, reduce drift that may accumulate, and help you accurately position your data in the real world so you can achieve an accurately georeferenced data output. Scanning a building like this is a common scenario where you would use user-selected targets, which I'll walk you through. In addition to the existing automated retroreflective target detection, Aura's GCP workflow has the versatility to use any target which can be identified and picked in the point cloud, such as checkerboard targets and paint marks, further increasing HoverMap's versatility for georeferencing across all capture methods. This new feature allows the environment to be used as targets, for example, the corner of a building or the tip of an arrow on the road. Or you can survey in targets, which could be checkerboard targets, reflective, or survey paint marks. Black and white checkerboard targets will provide good contrast to be seen with intensity in the point cloud to enable easy picking. The size of the targets can be variable. Typically, the closer you are to a target, the smaller you can use. The bigger they are, you can survey from a larger distance. Targets should ideally be placed every 40 meters for optimal accuracy. Although it's worth noting in feature-rich environments, you'll naturally need less targets versus feature-poor environments. You'll need at least 3 targets, though it's best to have more for added redundancy. While scanning, spend a bit more time near each target, as they'll show up more clearly in the point cloud. Using a paintbrush method with very steady motion will get lots of points on the target. Also, pointing the hover map at the target will capture more points on it, allowing for easier picking. We get roughly 3 times as many points at the end of the hover map than what we do out of the sides. Okay, so now we've finished up in the field. We've offloaded the data from the hover map onto this computer here, and we've also created a CSV file with the coordinates that we measured in with the total station. So here we have the ID, or the point name, the easting, northing, and height. If we also want to do Aura's automated target recognition on circular targets, we need to include the radius of the target in meters. I won't do it for this, so it's going to be all user selected targets, but that's where you'd put the radius if you had circular targets. So in Aura, we're going to click on Process Scan, select the GCP processing, navigate to the dataset, and then also we are going to select the CSV file that we've got. So here we've got confirmation that we're reading it in correctly. We've got the point ID, easting, northing, and height, and if we had the radius, it would be in this 5th column here. So we are happy with that. I will call this output GCP, and then we're good to start the processing. Alright, now the dataset is ready to align the point cloud to the coordinates that we've measured with the total station. Now what I like to do first is just restrict the amount of points that I can see, and I like to do that by range. So changing to the range filter and sliding this bar down, we can restrict it so we only have points within 5 or 10 meters. And then if I go back to intensity, so we're viewing the point cloud by intensity, I zoom in over here, you'll be able to see these highly reflective targets that we have. What I'm going to do is now scale out all of the low intensity points. So it means that target's going to be really easy for me to select. So this particular target that I'm zoomed in on is this first one, reflective big number 1. So what I'm going to do is highlight that, click on add target, and then I'm going to go to the selection tools and change to this lasso function. That's going to allow me to draw a circle around this target, and Aura is going to calculate the centroid of it. So by doing so, it's going to average all of those points and give me a really accurate center of that target. So I'll confirm that. And I will pan across to the next target, which is over here. And I'll do the same thing. So I'll select the target, click on add target, lasso these points, It's going to calculate the centroid, confirm, and the third target that I want to select initially is over here. Now, once I select this third target, we have enough information to be able to roughly georeference the point cloud to all of the coordinates that we've measured with the total station. So I'll confirm that. So if I click on this realign button, it's going to move these targets into the same location as the coordinates from the total station, and it's going to make all of the other targets much easier to find. So I'm going to click on focus on the left hand side here. And if I just scroll down so we can see the low intensity points as well, we'll see it starts to make a bit of sense with the capture. So we've got these other points that I haven't identified yet, but they do align with where this capture is currently. So just by selecting 3 targets initially, it's going to make the rest of them a lot easier to find. What I'm also going to do is just slide down this scalar bar so the intensities show a little bit easier, and then what I can do is scroll up and we can jump to the next target. So by clicking on this button here, it's going to jump to paint mark 1, which we can see right there. Now paint mark 1, it's the intersection of the inside of these 2 lines. It's the point that I want to choose, and if this icon's in the way, I can easily turn it off by just clicking this button here. So I'm going to highlight that, select the target, and we don't always have to do the lasso. So what I'm going to use now is just a single point that I'm going to pick, which then I can nudge into place. So I can move it by 1 millimeter at a time. This is by pushing the right arrow key, left, up, and down. And it's going to do it in relation to the view of the camera. So that's important that you're kind of looking perpendicular to the target when doing so. Once I'm happy with that, I'll click on confirm, and then I'll jump to paint mark number 2, zoom in and do the same thing. So I'll also hide this target so I can see it slightly easier. And confirm that. So now if I scroll across, we will see some of these errors that we're getting at the moment. Now this is using a rigid transformation, and we first aligned to just the first 3. So that's why they're better than these other 2 that I've selected. If I click on realign, it's going to reposition the point cloud, including all 5 targets now. These errors will get better as we rerun SLAM after this process. So this is just an indication of how things look at the moment using a rigid transformation between the point cloud that's already been created and the coordinates that we have. So we also have the option of selecting whether we want these as control points or checkpoints. The main difference is control points will influence the point cloud's final position, whereas checkpoints will not. They're simply an independent calculation of how well the point aligns to the coordinate that was measured. What I'm going to do is change this middle one to a checkpoint, and I'm also going to change these 2 paint marks to checkpoints as well. So then basically we're going to have checkpoints in between all of the control points, and I'll do the same thing for the indoor part of the scan as well. So I'm just going to jump to these checkerboard targets, and nudge them into place. Now I can also just rotate around to make sure we've got the depth correct, it's on the wall, and then we confirm that. Now my method for doing the reflective targets indoors is going to be very similar to outdoors, so I'm just going to hide all of the low intensity points, and that allows me to just see the points that I actually want to work with. So I will draw a lasso around these, and I can just rotate just to double check we've got the depth correct, confirm it, and go to the next one. So what I can quickly do is just click on realign and make sure these points are roughly correct. So if I scroll across and scroll up and down, we'll see the 3D error of these, and just make sure that it's not obvious that I've selected the wrong point entirely. And then the next thing I'm going to do is zoom out and I'll just display a few more points. What I'm going to do is choose which targets I want to use as control points and which targets I want to use as checkpoints. So I've already done that for outdoors. Outdoors we have this checkpoint as we're entering the building. I want to have a control point on each level here. I want these two to be checkpoints, these two to be control points, and these two to be checkpoints. So what I'll do is I'll scroll up, turn them all on so I can see them, and assign them so we're basically having checkpoints in between control points. So these two stay as control. I want to change these two to checkpoints. Those two stay as control, and I want these two as checkpoints. So I am happy with that. We've got basically a checkpoint between each control point the whole way through the scan. So what I'm going to do is confirm and continue the processing. Okay, so here we have the final result, and we can open up the PDF of the GCP accuracy report. The first page has kind of the metadata from the scan. The following page has the checkpoint accuracy summary. So we've got a RMS error of 8mm for the checkpoints that we used, and here it's broken down from X, Y, Z, and also the 3D differences per checkpoint that was used. And that's the continuation. And the last part is the control point error summary. So the RMS error for their control points was less than 1mm. Typically we see this because we're actually constraining the point cloud to these positions. So usually these are pretty good, and the checkpoint errors are a better independent check of the accuracy from the point cloud itself when comparing against those total station measurements that we got while out in the field. We also have the same output in CSV format, and here we've got the checkpoints, control position, the rigid error before we rerun SLAM, as well as the final error, and we've got the same thing for the control points down the bottom here. So this in the background is the geo-referenced point cloud. This is the final result that we have. Thank you very much for watching this video. If you'd like to learn more, please visit the Emesent website.